Hi, welcome to Pre-AP Physics 6.2 Ohm's Law. This is a tutorial on series circuit calculations of Ohm's Law. Again, series circuits. So let's go back to the analogies of series circuits. Remember we talked about it being one ladder, one slide, one pathway, one voltage, one resistance. Even if the slide got bigger and there were two panels, two bulbs, notice that the resistance is just the total of those two things, regardless of if they're the same size or different sizes, or if there are even more than just two. So, series circuits, the same current runs through each part of the circuit. So no matter what you measure, where you measure in a series circuit, you're going to get the same current. The total resistance is equal to the sum of the individual resistances. And the voltage applied is equal to the sum of the individual voltage drops. The voltage drop is proportional to the size of the resistor. If the circuit is broken or open, no current's going to flow because there's only one path. Let's look at that voltage drop. Voltage is a potential difference from the battery or the power source to any given point along the circuit. So in this circuit, remember that the electrons flow negative to positive. At A, we still have that 6 volts. And at B, we still have that 6 volts. But at C, because we have crossed a resistor, notice that we dropped voltage. We don't have as much as we did before. You all saw this when one bulb was brighter than the others because it had more or less resistance. D is right there next to C, so it has the same voltage available, but as soon as you cross D to get to E and then F, as the electrons come back to the battery, we have no more voltage available based on this circuit right here. The voltage dropped by 3 volts and 3 volts because the entire circuit had 6 volts available. That's series circuit voltage drop. Now let's look at some problems together. In this problem, it says 3 resistors of resistance 4 ohms each has a total resistance of 12. 4 is 12. And a total voltage drop of 6. Now, in order to calculate the current would simply be 6 volts divided by 12 ohms to be 0.5 amps. That's how you calculate current. The voltage divided by the total resistance. Look at this one. Again, notice the voltage is 6 volts, the total resistance is 15. Notice that the voltage drops more over the 10 ohm resistor than it does over the 5 ohm resistor. Okay, last problem. A series circuit has 4 bulbs of resistance 4, 8, 6, and 5 ohms. When the bulbs are connected to a battery, we don't know how big the battery is. When it's connected to a battery, the current is 1.5 amps. So what would the voltage drop or voltage across the 6 ohm resistor be? First, we need to find the total resistance. 4, 8, 6, and 5 is 23 ohms. Then we could find the voltage of the battery. Okay, how much voltage did we have? But honestly, we don't need to. The voltage drop across that 6 ohm resistor would be just the current of 1.5 times its individual resistor itself to be 9 volts. No matter what it had in the beginning, it's going to drop 9 volts across that 6 ohm resistor. All right, we're going to do more problems in class. Thanks for watching.